Hello, my name is Dirk Schober. I'm a solution engineer at Tableau, but this session is of course merely to be a private issue, so it's not any kind of sales thing or something. I was thinking about as you can see here on the screen, about my PV installation. So photovoltaic, for some in the world, yes, it actually works. I do not have to burn anything to get power into my house. I just need some sunshine, not too much today, and then I can use it in the house, or I can feed the excess power into the network, or if there's no sunshine, I have to get the power from the network directly. But I also have a battery, and I can use the power from the battery directly in the house. And of course, I can save a lot of money and energy with that. Okay, that's the background story here for why does it has anything to do with data. Well, as you can see, I have all the data available since the installation of that installation. And of course, I can do something with that data. Well, okay, I can do something with that. Why is that interesting? Because I want to use Claude here as an AI to do a ad hoc project for me, an ad hoc analysis with a recommendation, with a result. And I was triggered to do so by, first of all, the upcoming or the race of Tableau MCP a few weeks ago. For those who do not know anything about MCP, this is more or less like the USB hub for AI, so I can plug my Tableau cloud site into the local AI. That's maybe the best way to describe it very shortly. You will see it in action. And I was also triggered a bit by Tableau Tim, who's smiling here quite a lot, who was doing some data evaluation and investigation on a very critical level, and I really liked that video in YouTube, and he did that completely without Tableau. So I'm here to maybe discuss that and maybe see how that works for me. And to be honest, I did that before, but I'm trying to do that every time I'm doing a rehearsal recording. Like I never did that before, and that's also my first command to the AI here. Okay, so let's get started with anything like this. First of all, let's see, and I have some of the prompts prepared, so I do not have to type that all the time. Let's see if I can connect to my cloud site at all, to my Tableau cloud site. So for those who never seen Claude doing any kind of action, it's very typical that it goes, it's a local client, that's why it works with MCP. And it more or less thinks about what I mean first before doing anything. And sometimes it's doing more than I ask. That's also an interesting observation. And then it goes into the MCP connection, so that connection to my Tableau cloud site, and says, okay, list all the data sources. And list all the data sources in a certain project name that I was giving. So I have that data as you have been seeing. Oh, I didn't show you that. I'm sorry for that. And of course, I have to bring that in. I have here, of course, my Tableau cloud site with all the data that I collected from the API of my PV installation and collected here. And as you can see, I have a quite typical frequency or seasonality for Northern Europe. So not too much going on in the winter time, and quite a lot of green. Green means I'm using much of the power that I'm producing myself, which is the best way, of course. And I also have that on a detailed level for all the days that I want to look into. Okay. We could go into more detail, just that you know I have the data on my Tableau cloud site. I could also access it directly via the API of the PV installation. Also for that, there's an MCP server available, and I'm still thinking about how to build that into that little project here. But first of all, it lists all the data sources, and I know that I have number 9 PV daily data that I want to focus on. So let's give it that command to focus on exactly that. Also, I want to maybe use weather data at a later point of time. As you can see, I have weather data available here, and I want the system to simply ignore that, right? And let's be a bit unfair and try to challenge the AI for a very easy thing, and I'm misspelling the data source that I want to use. So I say something like ignore the weather data in that project folder and just use PV data daily, which doesn't exist. And it pivots immediately to daily data. Okay, so first of all, let me finish off with the general connectivity of the Tableau MCP server. I can also, of course, access workbooks and views and something like that. I even can access pulse metrics and the insights from that, which I will do here just for your information. Currently, at this point of time, most of the functionality that is available via API to change anything on the server, I'm not using. That's not used in the MCP server. Maybe it will come out later. So here I ask it to show a certain view. Well, also that view doesn't exist. It's named a bit differently. So let's see what it does. So it doesn't take monthly summary. It was correcting itself from my point of view to show the monthly overview. Actually, it tells me that I found the monthly overview and taken that as there is no monthly summary. That's good. And it explains me what it sees on that image. Well, I told it to show me the image, but I have to view it actually here inline somewhere. So that might be a concept of Claude as a client, that it focuses on the language and the explanations behind that. So of course it tells me what you can see here. The PV data spans from 22 to 25. That's my data, and it asks me what to do with that view. So we don't do anything with that view at this point of time. I just want to test that feature. So the next step would be to ask to do something similar as Tableau Tim was doing with his bookstore data in that other video, to just ask that thing to do data analysis or data visualization actually. And I've wanted to focus on the time frame up to June 23, because that's the point of time where we will focus on later on. So it queries the data source, it gets all the data of what I want to see. I want to see production and self-sufficiency. So it's a kind of verbal definition here, and let's see what it does. And the thought process shows me that in general it's creating a bar chart for production and a line chart for the self-sufficiency in percent. And self-sufficiency it calculates by consumption by consumption multiplied by 100. So while I was talking, it was creating an HTML file and presents me that HTML file, and also summarizes on the left-hand side, which I like very much, the chart features and the key findings. So key findings, there's a strong seasonal pattern. I have a self-sufficiency of 72 to 74% in summer, and in winter nearly nothing. And spring months show gradual recovery. I just have 2 years, so that's a bit limited. And I could certainly tell it to have some kind of other visual, but I didn't do that. So that's all coming out of the box, and actually it looks quite nice, right? It gives me a combo chart, and it would have taken me some time to get the data prepared and do some drag and drop in Tableau and go away from here. I do not ask the question here, but I want you to maybe think about very quickly how to share that with anyone. So I could download that file. It's a JSX file. I have no idea what a JSX file is, but sometimes it produces an HTML file, and I could take that HTML file and give it to someone. But actually, it's not connected to any data source, so it has lots of governance issues. It's just truth on my desktop and nothing else here. So that's just the starting point of a discussion of doing this way analysis versus Tableau, but that's not part of the story here. Well, anyway, I would think about, so let's introduce to you what my project here is, because I didn't really tell you completely. So if you look at that installation here, then I have a battery, that's good. And during the day, I'm filling the battery, and I'm also using, that's the blue part, I'm also using energy. And as you can see here, in the evening hours, I can use the energy that comes from the battery. That's the light blue shade. And that stops at some point of time because the battery is simply empty then. And that's okay, that's exactly the idea of the battery. In the evening, I'm consuming the power that I'm producing during the day. Well, in the winter months, I'm not feeding all too much into the network because most of the stuff I'm consuming myself. But and that's what you can see here, right? The self-sufficiency in the winter month is kind of low because I'm not producing too much. But in the summertime, I'm producing more than I need, and I'm feeding that into the network. The issue is, for me, that feeding it into the network is quite low efficiency because I just get a fragment of what I have to spend for a kilowatt hour of power. So the question is, would it help me if I have a second battery? That's a simple question. And I could ask that simple question, but first of all, let's go into that direction. What would be a typical discussion that I have with an expert that I want to do with the AI here? Well, the thing is, if I reopen that, then that feed-in, that self-sufficiency doesn't tell me anything, not too much, about how much power do I waste by feeding it into the network, because it doesn't bring me any money and I'm not using it. I have to, at some point of time, consume power again from the grid, which is expensive. So for that, I would need other measures. So I'm asking it to list all the measures in the data source. I think it did it before, but let's revisit that. So I have something like self-consumption and feed-in and production and purchased. Okay, so I have feed-in data, and that would be maybe the interesting part, in some kind of relationship with other data. So I'm pivoting here to another visualization to go away with not the self-sufficiency, but with the percentage of feed-in power. So again, it's carrying the data source, and it's producing some kind of visualization here. And look at that, it's creating a React visualization. And I didn't click on it, it's just showing me what it does. And that's kind of, sometimes if you have longer data sets, then for me this is a bit annoying. It could also do that in the background and just let me ask for details if I need that. But anyway, that's the way it works. So here's the feed-in percentage. And that's interesting because I was feeding in lots of my power in February 23, I'm not sure why. And also in August 22, that might have been summer vacation, so no one is in the house, then no one consumes the power for 2 weeks or something. And there's some statistics about that. There's an interesting inverse relationship, it tells me, key insight. When production is high in summer, a large percentage is fed into the grid because you're generating more than you can consume. That's true, and that's exactly my point. I could maybe ask something like, actually, I didn't ask that question ever before. So what I'm asking is something like, you are an expert maybe, you might be an expert on PV installations. So what would you do here? And I hope that it doesn't refer to my former transactions here, but it actually tells me that there's a wasted economic opportunity here, because I'm feeding in the summertime lots of the power into the network. So potential considerations: battery storage system, that's exactly what I want to work on. The 2 megawatt hours you fed into the grid over this period represents stored energy potential. Modern systems could capture much of your daily surplus. Yes, that's true. So we could also think about load shifting and smart energy use, consider a heat pump. Questions, do you already have battery storage? What's your current heating system? Look at that, it doesn't know that I have battery storage. It could guess that from the data, but okay, it doesn't know it. But that's the point, right? So it gives me some space, some questions where I could dig into. Okay, that would be a starting point for a deeper discussion, but let's go again. Let's go on with my project that I have. So here's the thing, I created a longer prompt for that, and I will run that while I'm talking. And if it takes too long, I will just speed up the answer process at a later point of time so you are not bored. So the idea is to take the high feed and create an additional power storage. I just say additional. To clarify this question, I want you to act as if we were in September 23, because that was the point of time where I did that decision or not. Until then, I had 4.2 kilowatt hours of battery storage, and based on the data until then, I want you to calculate a return on investment calculation. With investment is something like 2,500 euros. Current price for energy that I purchase is 40 cents, and the sell price is 8 cents. So I'm kind of wasting 32 cents for every kilowatt hour that I'm consuming from the grid, but not taking from the battery. So it architected the ROI calculation, and it tells me time period, and it repeats all the assumptions. That's good. To analyze that, I need to calculate ROI. The key insight is the additional battery would capture energy that is currently being fed into the grid, stored it, whatever. Let me query the data. Okay, so it's a fairly small assumption that it does. Excellent question. It's always an excellent question. So analyze the energy data. Good, I have the data. It's something like total production, consumption, feed-in, and so on. Current situation, they are feeding 2.8 megawatt hour into the grid at 8 cents. They're purchasing so much from the grid. So the net cost is 1,400 euros over 16 months. The question is, how much of the feed-in would be captured? Yes. Key factors: additional battery would capture excess production during the day. This stored energy would be used in the evening. Benefit is avoided purchase cost. How much can realistically be captured? There are daily patterns, not just monthly totals. The battery can be fully utilized or not. Actually, it cannot be completely fully utilized because always 10% stays in the battery for buffer reasons. Seasonal variations without granular data, I need to estimate realistically. Yes, that's what you need to do. But actually, here's the first stupid thing that it more or less does every single time when I'm trying that. It says, without granular daily data. If you remember the data source that I was asking to use, it's called PD daily data. So it really contains daily data. I think it's just misled because I was asking for monthly data before. So it's using also monthly data here. And let's look at that financial picture. Says roughly 300. Okay. So it tells me what it calculates, and we do not have to go into all the details. It's presenting two files after it produced it and gives me the key findings. And it gives me the key findings on the left-hand side and also in the file. So let's look at the file. And actually, the thing is, it looks differently every time I ask. So here's the battery storage analysis. Energy flow. So it summarizes all that. Current battery performance, 43% of production, key observation, energy arbitrage, opportunity, price differential, blah, blah, blah. Summer, we have 150 days, storage potential, spring, fall. So it differentiates between summer and winter. High excess, excellent battery opportunity in summer, of course, yes. Account for efficiency, the 90% round trip efficiency actually never explains what that is, and it always assumes that. I could ask for, of course, what that means. I think it means exactly what I was talking about. When the battery discharges, it always keeps 10%, and that's why you do not have the full capacity available. The reason for that is technical, and it just needs to do that because it might be that you are not producing anything for a few days, and then you need that 10% maybe for keeping the system alive. So savings calculation, okay. Foregone feed-in revenue, 56 euros per watt. Energy annual savings calculation, 930 kilowatt hours over 60 months. I'm not sure how it calculated that. Maybe I missed it. Oh, that's storage potential here. Maybe this is referred to. That's not clear to me, but I don't have the time to dig into that here. ROE scenarios, investment, blah, blah. Simple payback is 11.2 years. Let's take into consideration a 3% annual price increase, which would be good for the calculation because then the purchase price raises, and that means more annual savings with the additional battery. So the break even is between 9 and 10 years then. And scenario 3 with a 5% annual price increase, then the break even is between 8 and 9 years. Okay, additional considerations, positive factors, battery warranty. Most systems have 10 years warranty. That's good site information, which is good that it brings it in, because in a human-driven analysis, you would have to consider that and you have to know it, and a simple controller might not take that into consideration. Grid independence, future EV charging. I have an EV electric vehicle, but it doesn't know that. Feed-in tariff reduction risk may decrease for new installation. Why should that matter? Because it's not a new installation here. Energy price protection against price spikes. Yes, carbon footprint. That's also one of my drivers. Negative factors: battery degradation, maintenance cost, absolutely minimal because you just plug it in and use it. And technology improvements, and that might lead to battery prices falling. So you would need to produce more. You would need to save more than the battery price increase. Critical limitations. The winter months are the bottlenecks. That's kind of clear. In addition, it won't help much in winter because there's simply not enough solar production to store. That's good. Marginal ROI, the verdict. Proceed with caution. Okay, so, and it gives me some consideration that we've seen before, and it also gives me better alternatives to consider. Why these are better is not completely clear to me. Or I should wait 1 or 2 years because the prices drop. Okay, I asked it to go back into 23, kind of a useless discussion at this point of time. Anyway, so it's kind of a good summary. It's a good calculation based on the fact that it has, and it looks valid. And for me, this is the most important drawback. two drawbacks. One is it's always different. I did that like 5 times now, and it's always different, the results. And I'm thinking about why. The other thing is the presentation is always different. So in this case, I have no graphics at all. I just have a summary, a written summary, like a management report, which is maybe okay. But what if I want to change a parameter? I have to recreate everything, and also reproduce all that here. If you do invest now, negotiate hard on price. Okay, yes, that's good. It gives me good suggestions, but it also tries to show me or suggest to me that this is the only solution, that this is completely right? So there's a risk here, because I have to trust that calculation, or I have to really ask for everything. So let's ask, why should I maybe not trust in your analysis? So let's look into the thinking here. This is an excellent, important question always. Data limitations, right. Assumptions I made. Battery utilization, I assumed 90%. I don't know the actual charge-discharge patterns. That's correct. Assume battery can capture the shiftable energy I calculated. Missing information. I don't know your actual consumption patterns. That's true. I don't know if you have time of use pricing available. Blah, 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 blah. So there is some limitations. You could have thought about that, and you could have asked me questions, right? You could have asked me all these questions, but you wanted to make it easier for yourself, but assume to bring me this as the only truth. So as always with AI, you have to be cautious. Claude is an AI and can make mistakes. It's not really a mistake, but it's giving me something that I have to trust. What I'm missing, so it summarizes everything. Only 60 months of data, that's true. I didn't give you more. I asked you to not take more. Critical assumption, 90% efficiency, shiftable energy, your existing battery, is it operating optimally? What is the current state? Now it's asking me those questions. Is it already degraded? Can it work efficiently with a second battery? Your consumption profile, office job, family with kids, electric heating, your system specifics, inverter capacity, and so on. Economic uncertainty, I haven't properly modeled battery degradation. So it's going in all these things and repeating it over and over again. The biggest flaw, I'm using monthly aggregates. That's true. This is critical. The battery works on daily cycles. Not only that, think about, let's look into that chart here again. So if somewhere here is midnight, then I'm consuming the battery power from the day before on the next day. So even the daily data wouldn't help completely to make a really realistic picture. But we are going into that. What would disprove my analysis? Hourly data for at least a week per season. Okay, I'd be less confident if the honest truth, real data from your Tableau data source, sound financial modeling principles, of course, monthly aggregates, no information about consumption. Okay, so it gives me all that, but it didn't consider these two things. First of all, it doesn't ask me if we have storage data available, right? It doesn't ask me that. And it's also not asking me, or it's not coming by itself to the point that I have daily data in that data source. So I could skip. Before I was trying to just ask it, hey, why did I name that data source PD daily data? But it's interesting, right? I gave it the command before to focus on monthly data, and from then on it focuses on monthly data and is not able to pivot itself to something else. So I give it now a hint that I say, to make the calculation exact, you would have to find days where storage reaches 100%. And I give you that storage data because it's available. I didn't allow it to access the storage data before because I was excluding that. But here's where I open up the world to a second data source. And before I was asking it to use the storage data from the API of the PV installation itself, actually, which is also available via MCP. And that's an interesting approach to mix things together. Actually, it took too long, and also it doesn't store the data from these old times for storage for some reason. I'm not sure why. So there's much more precise approach. It doesn't challenge my approach, by the way, right? Because only those days would there to be excess production available for additional battery to capture. Let me access the power storage all details data source. And here's what it finds. It finds a timestamp and battery percentage state. So I need to query the period, find the battery percentage stage where it reached or exceeds 100%. How can it exceed 100%? On those days, calculate how much additional energy could have been stored. And it doesn't give me insights how it does that. Okay, so validated the assumptions. Now I need to count the days where battery reached 100%. On those days, get the daily production and feed-in data, calculate how much additional energy could have been stored. And actually, it did the same thing this morning, and it gave a slightly different approach again. Okay, so one thing here on the technical side, it creates a Python script here where it puts in all the data that it has and executes that Python script. Why does it do that? My assumption is that it uses a Python script for a good reason, because it knows that itself, a large language model, is not that good in data calculations, right? And a Python script doing calculations and aggregations is far more efficient and far better suited for that purpose. And it doesn't hallucinate that much. So now it's counting the days, also with a Python script here, validating the assumptions. Perfect. So 311 of 487 days have the battery has. This is the result that it had before. I should query the daily data to get actual production and feed in. Okay, so it's going back to the data source and knows for these days I need to take the data of production and feed in. Does it get feed in or storage? Feed in, okay. So I think it goes back into the data and tries to find how much data feed in, and I hope that it doesn't assume that all the data, all the power that I feed in could be captured, because that would be, of course, completely wrong. Also, one thing to consider, of course, this is not the complete truth. It would also be important to know when on the day the 100% has been reached, because only the power after that was fed in, would be available for saving in the second battery and reusing later on. Okay, so here is the verdict: corrected battery ROI. Critic finding: your assumption was correct. You were absolutely right. Actual battery performance data, how many days it was, how many percentage of the full days were there. Key insight: the battery was completely useless for additional storage during December to January. It never reached 100%. So it was not useless, by the way. That's a bit harsh, because of course it stored power that I was consuming. It was just not useful for this calculation. So I like this. I do not like, to be honest, this strange language of absolutility, if I can call it that way. So it does some kind of calculation here: summer month, whatever, spring, fall. Let's skip that a bit. So round trip efficiency 90%, annualized how many kilowatt hours, avoided grid purchases, whatever. this is lower than my original estimate, and revised ROI scenarios, whatever. The brutal reality, it's brutal, yes. Additional battery provides zero value. That's true, but only the additional doesn't provide. The investment doesn't solve your biggest problem. So why this matters? Solar production is minimal. First battery barely charges. Okay. Investment is worse than originally calculated. That's true in your assumptions. Corrected numbers. The hard truth is financially marginal to poor. Even with 5% annual price growth, the break even is not within 10 years. So I didn't tell it 10 years. The 10 years limit is kind of a thing that you could assume because of that warranty thing. I'm not sure about that for that battery that I was buying, but anyway. What would actually help in winter? More solar panels doesn't help. Because if there's no sun, then more solar panels also do not help. Also, I have to invest into them. Heat pump optimization, preheat the house during midday. Store heat, how can I store the heat? And can I store heat better than electricity? That's bullshit, I'm sorry for that word. Do not invest. Okay, so the result is good, but some of these wordings are simply not really helpful from my point of view. Your assumption was correct, and again, it gives me that result with a certainty that this is now correct. But it's not. But it's not. So next step would be to say something like, hey, did you consider that I can also use the power on the next day? I will skip that for the time being. I will want you to show you some of the intelligent things that it does here. So let's dig into that. If you want to consider all the data until 23 and compare the weather data. So the weather data is available actually via weather API that I have connected on MCP. But what I know, what the AI currently does not know is it will show me that also that radiation, how much sunshine there was. And I'm pointing it to not use the Tableau data sources for this, because I wanted to show you something nice of the AI here. So it tries to go into this MCP connection for getting the current weather or the historical weather. Let me get radiation data for each month and compare. I need to be careful. The user already has solar production data but they want me to compare it to weather data to see if blah. Okay, so it does what I want. Get weather details for my hometown. Hunting historical solar radiation via web search. So the weather API doesn't provide historical data going back to 22. That's a problem. And here is the nice thing about Claude. It's kind of intelligent enough to say, okay, you asked me to use the API. I can't do that. You asked me to not use the Tableau data in this case for demo purposes. So I will do something else, right? I will go to the Deutsche Wetterdienst, the German weather service, but that blocks API requests from robots. So it tries the weather API again. Why? Interesting. Web search. It goes to previous search results. That's interesting because I told it not to refer to any former chat. But anyway, I will skip through that. You see, this is the nice thing, right? Instead of digging into data, it tries to get data from websites. That's kind of good approach to get at least some assumption. I was just asking something like, was that a typical sunshine year or not? And so I do not ask for specific data or exact data. And for me, that's completely okay to search into some websites and just find information about if that weather in that year was typical or not. Instead of, and it gets some kind of exact data, just not for my location, to be honest, right? So it assumes that German data is the same as Northern German Osnabrück data, which we all know is not necessarily true, but maybe for this simple question, it's okay. So the interesting part is it goes again back to I'm not sure why it repeats itself. So it did that web search 3 times now for the comparison, okay. And now it's going back into the hottest year, sunniest year ever recorded. This means the ROI analysis is likely too optimistic. And because it thinks it might be too optimistic, it goes again and does a comprehensive analysis and comes up with a new finding here. So to summarize that, I know from former run-throughs that the year that we are referring to was exceptionally sunny. Which is of course not good for my ROI calculation, because it means that normally I do not get that much results. But again, I was hinting the system to look for that. There was no idea from the system itself to do that check by itself. So the analysis calculation, or that work in the background, is kind of very, very good, very, very efficient. But what I do not like is the different results every time I ask for something, the different presentation of the results, and also that absolutility, if that word exists, of how it communicates to me that this is now the real solution, that this is the true analysis, it's now corrected. And so here's the bold result, right? No matter if I should do the investment or not. So be suspicious here, whatever comes out of that. It was just for showcasing that it can also refer to something else. I was commenting on that before. Let's go on with the next step. So the last step maybe in that calculation here, and that might take a while for the analysis, I now tell it that I actually bought that battery in October 23. And I wanted to verify if my investment was as expected or not. I just want to show another thing here. I tell it to use the daily basis, PV daily data daily. Instead of monthly aggregate assumptions, also look into the reduction of feed-in power that is realized on a daily basis after the investment. So I really tell it to use daily data now, because my challenge here is daily data means more data, because we are looking at 5 years now. It's not too much, it's 1,500 days or 1,700 days. But we are also kind of for a longer time in the discussion, and that's why from time to time I get that compacting our conversation here so we can keep chatting. That appears the longer you do that conversation. What I could do is store the in-between results and open up a new chat, take the in-between results, and then go on with the next step. This is excellent. We can now do a before-after comparison. Yes, that was my idea. Let me start by checking the data source, metadata available, data range. Excellent. Again, it's compacting. So it's kind of, it has an alert here. I'm not sure why. request ID 20, request failed with status code 400. Not sure why. Key tasks, query daily data. Yes, we know that before. Which is on the one hand good that it retries things that it, instead of saying something went wrong, I just try to do something else. It should inform me, but it maybe doesn't find that necessary to inform me. Identify. Okay, so the logical UID of the data source doesn't exist. I didn't tell it any ID. I told it the name, and maybe I did it wrong again. But anyway, it should be smart enough to. It is smart enough to be fair. To go back to the original data source. By the way, it doesn't challenge me in my command. I'm telling it something like, perform your analysis on a daily basis. If you think about the reduction of feed-in power on a daily basis, then you might get that, of course, wrong again, because if you compare the 1/20th of January with the other 20th of January, you will get some reduction, but that doesn't tell you anything. So it could give me that feedback, hey, that doesn't make sense, because the feed-in reduction makes sense merely maybe on a weekly basis, on monthly basis, but not on a daily basis. But okay, I'm the boss here. I gave it that command, so it could challenge me. But on the other hand, I wanted to execute my commands, right? Okay, here's the result coming up. I was skipping that a bit, and we do not have to go into all the results here. So the fact is that the battery impact analysis, the battery is working, but with significant limitations. Feed-in reduction achieved. Yes, we captured a lot of power over the 14 months. Why 14 months? I could doubt that again, because I didn't tell it. It was taking 14 months before, and that's why it's taking 14 months after, which is not true, because the time after, to be fair, is not only until December 24. Actually, I have the battery until today, so that's January 26. Why not use all the data for comparison? Because I'm not sure. It didn't ask me, it just assumes that this is correct. So maybe other things would be correct. So performance metrics, the change, the feed-in change, whatever. So what I like is that it gives me that analysis, and it gives me some kind of verdict with that. As I said before, I sometimes do not like that verdict is kind of absolute. I like, in most cases, the way it presents things, but at the other time, on the other hand, it doesn't. It does a different presentation every time that I'm asking. Every single time, it's looking differently, and then it gives me that summary here. And to be honest, it would have taken me much longer to do that by hand, but I have to be intelligent enough to look into that, to find the assumptions, to ask for the assumptions, and to be fair about the results, but also be very critical about the results. And still, I do not understand everything what it did, compared to something that a typical controller would do, would be very detailed, especially German controllers, to really find if this is true or not. So I cannot calculate anything here. It gives me also things to investigate. Extremely high consumption days. Why should I investigate? What's driving these spikes? Well, I don't know. I had the power. The car maybe charged twice. It doesn't come to that idea. Battery capacity questions. How large is your battery? I gave you that idea. Is it reaching full charge in summer? That's stupid, that question, you know that. Could a smaller battery, okay, it doesn't know that I can only add the same capacity. Okay, there's a verdict and a conclusion and a verdict and a final verdict and data quality notes. Confidence level high, real operational data shows actual performance. Okay, so that's our conclusion. I could give it the hint to also do the calculation until today, or ask something like, maybe that is my last question, and I do not want you to wait until the end, but I will just throw it in. Why didn't you consider the complete data set until today? Because that's available, and it would be a good calculation and a good completion of that calculation. And I hope that you understand that I really like that approach. It's kind of, I have the solid base of data in the Tableau data source. So at least I can make sure that all the calculations that it does are kind of on a solid basis. But on the other hand, I do not have complete control of what the AI does locally here. I have technical limitations locally. There's a memory limitation for Claude Desktop. I have limitations for the credit consumption. And especially, I do not like that it kind of acts differently anytime and that it shows me the results in a way that are so absolutely correct when they are not. And I have to be the intelligent person in the room to not trust the AI. And actually, if I would be in a real world situation, I would even go deeper into that discussion with the AI, because I mean, the real use case wouldn't be an investment of 2,500 euros, but maybe a complete new production site. And with that complexity, I'm not sure how the AI would react and if it would be able to do that anyway. So I'm coming back a bit later to my computer just to see what came out of that last command that I didn't want to bother anyone with. But I issued that just for completeness, and it was about considering the complete data set. So what did the AI do when I was asking about the actual usage of the additional battery? It was analyzing more or less the same number of months after the installation that it was analyzing before. So if you see that, it's just 1 year more or less. And as we all know, years can be different. So I was asking, hey, why didn't you consider the complete data set, just to hint to the fact that itself could have come to the idea that in the PV daily data source is not only daily data, but also until today. So that's early 26. And again, it says something like, I get annoyed from, in terms of AI, to be honest, is that it says, you're absolutely right. The reason why the AI doesn't do what I'm intending to do is, of course, my very limited prompting. But if we would consider the fact that people in the future would sit in front of something like Claude, take some data set, do some analysis, and they have no knowledge about how to prompt or not too deep knowledge, they would just ask their own questions. And without any governance of, it would just run into issues, quite obviously. Then because as you can see here, it's now considering all the data until end of 25, and it recognized, which is, by the way, I think it's wrong, it recognized that the battery is degrading heavily. So it says to me the payback is now 43 years, not 9 years. How can that be? I'm still saving something, even based on the data of the AI. And As I said, I did that analysis before and never came that result, so I would highly doubt that this is correct. And it's now repeatedly saying to me that the battery is degrading and something is wrong here. And then it says that I'm spending 179 euros more than before the battery. I'm not even saving any money. How does it come to that? Oh, okay, because it says I have a massive consumption increase problem. Hey, dear AI, I'm consuming more because within the period of what we are looking at, I was buying a new electric vehicle. So quite naturally, I'm consuming more power. That's not a problem of the battery. Yes, I'm spending more money on power consumption, but that's not the problem of the battery. It's a general thing. So that means the net result is not a result of the battery, it's a result of my additional consumption. So it's simply wrong what it tells me. I sincerely apologize. The battery investment is not working as it should. Something is seriously wrong. Either battery degradation, changed consumption patterns, or system misconfiguration. Yes, so it's not, I mean, why does it warn me in any way? Because it wants to highlight that big discovery, but the discovery is, in my eyes, on the one hand wrong. Again, I do not get any additional information on how it's calculating these 179 euros per year. It's not considering that I have changed consumption patterns. It sees the changed consumption patterns. It's maybe there's a battery degradation, which is natural, but it can see the consumption patterns being changed. So I'm quite disappointed here. I'm happily surprised about the workload that it's taken from my shoulders by taking the data, doing the analysis, putting it all together, writing a text about it. But if I'm in the end have to go back and reprompt everything, recheck everything, and correct everything, then it doesn't help me. It's just a waste of time, to be very honest. So that's an interesting outcome. I wanted to come out with a bit more positiveness. What's positive is, of course, I have Tableau in the background with a solid data source, which if I would have more business logic in that data source, not just data, then it would ensure that at least any data that comes out of that data source is kind of correct and governed. But everything beyond that leads me to the point that we are not only replacing Excel hell with, so uncontrollable Excel hell that we had like 15 years ago, with dashboard hell, which can be governed if you have a proper platform, but sometimes it's not, because companies have wrong, in my eyes, wrong strategy. And it comes out that in this case, I'm going back to ungoverned AI, which is not only ungoverned, it's uncontrolled, and it's just wrong. So thank you for your audience, and that's a happy, that's a kind of surprising end here. But thank you for your audience anyway. Thank you.